Welcome to Fun Facts Daily, your source for just the good stuff. Monday through Friday, we're bringing fun facts and news you can use, all carefully curated to uplift and inform. So give yourself a break, relax, and learn something awesome in just a few minutes every day. Hi everyone, I'm Kyle Wood, and today we're going to be learning about rocks. But before we get into the facts, let's warm up our brains with a little challenge to see if you can tell fact from fiction. Consider this. We usually think of rocks as heavy, solid objects that sink straight to the bottom of a lake or an ocean. But would you believe that not all rocks will sink in the water? Could there be a type of rock that actually floats? What do you think? We'll find out at the end of the episode. Now for your word of the day. Our word for today is petrology. That's Petrology. Petrology is the specific branch of science concerned with the origin, structure, and composition of rocks. While a geologist studies the Earth as a whole, a petrologist looks very closely at the rocks themselves to understand how they're formed, whether through volcanic fire, deep pressure, or settling sediment, and what that tells us about the history of our planet. Now, if you're wondering how rocks are formed, there are three basic types. Igneous rocks form when molten magma or lava cools and hardens. Another type, sedimentary rocks, are created when layers of mud, sand, and pebbles get squashed together over millions of years. And finally, we have metamorphic rocks, which are the shapeshifters of the geological world. These start as one type of rock but are transformed into something completely new by intense heat and pressure deep underground. The word petrology comes from the Greek word petra, which means rock or stone, and logos, which means study or discourse. You might recognize the root word petra in other common words like petrified, which means turned to stone, or even the name Peter, which means a rock. Time for your daily high five, our top 5 fun facts about rocks. Number 1, some rocks can actually make music. I promise I'm not subjecting you to a terrible dad joke here. When I'm talking about rock music, I'm literally talking about rocks that can be used to make musical tones. There's a strange field of boulders in Pennsylvania called Ringing Rocks Park, where the stones sound like bells when you hit them with a hammer. Most rocks would just make a dull thud sound when you strike them because they absorb the energy of the impact, but these specific igneous rocks, made of material called diabase, ring out with metallic musical tones. Scientists believe this acoustic phenomenon happens due to a combination of high iron content and the incredible density of the stone, which creates high internal tension known as residual stress. Unlike most rocks that have microscopic cracks which dampen vibrations, these rocks are solid and elastic enough to vibrate as a single unit, much like a steel bell or tuning fork. When you strike them, the energy travels through the rock without dissipating, allowing the sound waves to resonate at frequencies our ears perceive as musical notes. Number 2, there are rocks that are actually a bit flexible and can bend without breaking. Typically, stone is strong and rigid, but brittle. However, there is a rare type of sandstone called Itacolumite, which is actually flexible. It can be found in Brazil, India, and the southeastern US. The rock is composed of loosely interlocked quartz grains. This unique structure acts like a microscopic ball and socket joint system, allowing the grains to rotate slightly against one another without fracturing the stone. Geologists believe this happens when the original cementing material dissolves over time due to weathering or metamorphic processes, leaving behind a porous, interlocking framework. This loose structure allows thin slabs of the rock to wiggle and bend under their own weight, almost like a piece of stiff rubber. Number 3. Some rocks in Northern Ireland naturally formed into neat geometric shapes. At the Giant's Causeway, you can find about 40,000 interlocking rock columns that are shaped like perfect hexagons. These pillars look like they were carved by humans, but they were actually formed by a process called columnar joining, which occurs when thick volcanic lava cools and contracts. As the molten basalt lava cooled rapidly from the outside in, the rock contracted and shrank, creating tension that needed to be released through cracking. Nature is very efficient, and the most energy efficient way to relieve this stress over a large surface area is to crack at 120-degree angles, creating six-sided shapes. It's the same principle of efficiency that bees use when building honeycombs. The hexagon allows the rocks to pack together tightly with no wasted space, resulting in a stunning, geometrically perfect landscape. Number 4. Some rocks have a secret glow. If you walk the beaches of Lake Superior in Michigan at night with a UV light, you might find some glowing orange rocks known as yooperlites. These seemingly ordinary gray stones are actually syenite rocks that contain a fluorescent mineral called sodalite, which were transported south from Canada by massive glaciers during the last ice age. The science behind this glow is called fluorescence. When the ultraviolet light hits the sodalite, the electrons within the mineral's atoms get excited and jump to a higher energy state. As these electrons inevitably fall back down to their resting state, they release that extra energy in the form of a photon of visible light, in this case, a bright orange hue. This means the rock isn't just reflecting light, it's actually absorbing invisible energy and transforming it into visible light right before your eyes. And our fifth and final fun fact for today, the oldest rock formation on Earth is nearly as old as the planet itself. The oldest known rock formation is the Acasta gneiss in northern Canada. It has been dated to about 4.03 billion years old. The Earth itself is estimated to be about 4.5 billion years old, meaning these rocks have witnessed almost the entire history of our world, surviving the Hadean eon when the Earth was a volatile, hot, and hostile environment. These rocks outlasted the dinosaurs. Through millions of years of natural erosion and shifting tectonic plates, these rocks have stood their ground. So, how do we know these rocks have been around for billions of years if they're older than history, humanity, and maybe even older than all life on Earth? Great question. Glad I asked. Scientists determined this age using a method called radiometric dating, specifically looking at the tiny crystals called zircons found inside the rock. Zircon crystals are incredibly durable and trap uranium atoms when they form. Over billions of years, that uranium decays into lead at a very specific constant rate. By measuring the ratio of uranium to lead inside these microscopic time capsules, petrologists can calculate the age of the rock. Now for some news you can use. A rock tumbler isn't the only way to turn a dull stone into a shiny gem. You just need some sandpaper and a tube of toothpaste. Start by rubbing your rock with coarse sandpaper to remove the bumps, then switch to a finer grit sandpaper to smooth out the scratches. And finally, put a dab of non-gel toothpaste on a denim cloth and buff the rock vigorously to give it a brilliant shine. This technique works because of abrasion. The coarse sandpaper levels the microscopic mountains on the rock's surface, while the finer sandpaper removes the valleys. Toothpaste acts as a microabrasive polish. It contains tiny particles of silica or calcium carbonate that are hard enough to remove the tiniest imperfections, but soft enough to leave a glass-like finish. This allows light to reflect off the stone rather than scattering, and it creates that beautiful polished wet look. You can preserve that shine by rubbing a little mineral oil over the top to fill in the pores and seal it. And now for the moment you've been waiting for. At the beginning of the episode, I asked, could there possibly be a rock that would float on water? Well, that's a fact. There's a rock called pumice that's famous for its ability to float. Pumice is an igneous volcanic rock that forms during explosive eruptions when superheated, highly pressurized rock is shot out of the volcano. It cools extremely rapidly in a process called quenching. The process is so fast that gas bubbles trapped inside don't have time to escape. They freeze in place, turning the rock into a frothy, foamy structure. This creates a rock with very high porosity, meaning it's full of tiny air pockets. Because the volume of the rock is mostly air, its overall density is lower than that of water, so the stone will bob on the surface like a cork until it eventually becomes waterlogged. Now, I hope you enjoyed learning a bit about rocks with me today, and be sure to tune in every weekday for even more fun facts. Fun Facts Daily is an Airwave Media podcast. It was written, recorded, mixed, and edited by me, Kyle Wood. Thanks for sharing a part of your day with me. Be sure to follow Fun Facts Daily on your favorite podcast app so you can keep the good stuff coming your way every day. And if you like the show, please do me a favor and leave a kind rating, review, or just tell your friends about it.